Synchronous counters, clocked counters with better timing characteristics. Synchronous counters are counters where all flip-flops are triggered by the same clock signal simultaneously. Let's explore the key characteristics of synchronous counters. First, fast operation. There is no propagation delay between flip-flops. Second, better timing. All state changes occur at the same clock edge. A basic structure of synchronous counter contains multiple flip-flops like FF0, FF1 and FF2. All flip-flops gets the clock signal from the common clock signal. The clock signal is connected to each flip-flop. Here is the VHDL implementation of a 3-bit synchronous counter. The entity is named as sync_counter. It has 3 ports. CLK is an input of type standard logic. Reset is an input of type standard logic. Count is an output of standard logic vector of length 3, that is 2 down to 0. The next state logic equations are Q1 plus is equal to Q0 XOR Q1. Q2 plus is equal to Q0 and Q1, XOR Q2. Each flip-flop input depends on current states of previous stages. Let us explore the advantages of synchronous counters. First, higher speed. There is no cumulative delay. All flip-flops change simultaneously. Second, no glitches. The outputs are stable with no intermediate transient states. Now let's explore some applications of synchronous counters. First, frequency dividers, creating precise clock signals at different frequencies for timing circuits. Second, digital systems for address generation and control sequencing in processors and memory. In summary, synchronous counters provide superior timing performance with simultaneous state changes and eliminate propagation delays. They are essential for high-speed digital applications. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.